Hello everybody. Just wanted to put a quick video out on one of the lessons to try to keep you all up to date with the learning, even though I'm still out of the classroom right now. So this is going to be for notes number 43. I know that I kind of skipped over notes number 42, but that's going to have to kind of go the wayside, so don't worry about notes number 42. We're just going to start up on notes number 43. So notes number 43 is all about greatest common factors. So we're going to be going over factoring basically for the rest of this chapter. You really have to master this GCF stuff, greatest common factor, in order to be successful with the other factoring techniques that I'm going to show you. So let's go ahead and try this out and try your best to understand it. If you have any questions about it, feel free to send me messages, okay? So one of the best ways to connect this to prior knowledge is when you multiply two numbers, basically, let's say 6 times 4. It's like you're bringing them together. 6 times 4 is 24. When you're doing the act of factoring, it's like you're breaking back apart the 24. You're trying to find out two numbers that multiply to be 24. Now, these two numbers could be any two numbers. I just picked 6 and 4 again. You could have done 8 and 3, 12 and 2. So factors are just any two numbers that multiply to be that number. So factoring is breaking back apart, multiplying is bringing together. It's kind of a simplistic way of thinking about this. Now, as far as polynomials go, you should have been practicing distribution a whole lot with all of those assignments I've been giving for sub. So hopefully you've got pretty good about doing this. So if you see a 4 on the outside times this group x plus 5, basically what you need to do is just distribute the 4 to the x, so 4 times x. Distribute the 4 to the 5, 4 times 5, you get 4x plus 20, okay? So that's nothing new. Now, with factoring out a greatest common factor, basically we're going to do this process, but in reverse. We're going to start with the 4x plus 20, and then we're going to break it back apart so that we get the 4 times the x plus 5 again. So the way you want to think about this is your problems now are going to start off just looking like this polynomial, this binomial right here. You basically just have to figure out what's the biggest number that goes into both 4 and 20, and that's 4. So you got a 4 times x, so 4x breaks apart into a 4 times x. 20 breaks back apart to a 4 times 5. Now, we're at the same middle step right here. So if you look at it, we broke both of these back apart. Now we find out what both of these terms have in common, because just like distribution gave the 4 to both terms, for factoring, it's like you're taking it back. So the number that was given to both of these terms or multiplied to both of these terms was a 4. So it's basically like you're taking that 4 back away from the x and the 5, and then those parts go back inside of the parentheses, okay? So that's basically what factoring out of GCF is. Now let's look at a little bit more complicated example right here. So we got 20x squared plus 15x minus 25. So this is a trinomial. Now what you're going to do is you're going to break each of these pieces into its prime factors. We did this back when we were doing square roots with the factor trees. So like a 20, you can draw 10 times a 2. 10 times a 2, and then 10 is a 5 and a 2. So, or 4 times 5, and then 4 is a 2 and a 2. But basically, you can break apart the 20 to a 2 times a 2 times a 5. And again, that's with the factor tree that we did before. X squared is an x times an x. 15, same thing, that's a 5 and a 3. And then an x, 25 is a 5 and a 5. Now, in order for you to take a number out in order to figure out what was distributed, it would have had to been distributed to all three parts. It can't just be in two of these. It has to be in all three of them. So if I look at the red group, the black group, and the green group, the only number that's in all three of these is this 5. So what I do is I take out that 5, okay, double check. So in the red group, black group, and green group, there's no other things in common. So everything else goes back inside of parentheses, okay? Make sure you keep them together so that everything from this 20x squared goes here, 15x is in the middle term, 25 is the last term. And then the signs just kind of stay the same, okay? So the plus comes down, minus comes down. And now just clean this up a little bit. 2 times 2 is 4, x times x is x squared, 3 times x is a 3x, and then minus 5. And then that's it. That's basically taking out a GCF. So now one way you can check your work is distribute back in the 5. 5 times 4x squared is 20x squared. 5 times 3x is a 15x, and 5 times negative 5 is a negative 25. All right, so that's basically what you're going to be doing today with today's work. Okay, hopefully that makes sense. The next part is going to be the notes themselves, so you can choose to keep watching, or if this makes pretty good sense to you, you can go ahead and just try out the worksheet, but I'm going to go ahead and fill in the notes numbers 43 for this next part. Alrighty, so this next part is just on filling out these structured notes that we usually do in class to kind of get a better understanding of how to get the greatest common factor out. So again, the best way to kind of approach the GCF, greatest common factor, is to really make sure that you understand the distribution thing first. So with distribution, again, you would take this 3x times this 2x, so that'd be 3x times the 2x, and then you take the 3x and multiply it to the 5. So then you get plus your 3x times the 5. And then now you just multiply those pieces together. So 3x times 2x is a 6x to the second power, plus 3x times 5 is a 15x. So hopefully you've had quite a bit of practice with this by now, since we did a lot of, or you should have been doing a lot of this with the substitute while they were there. So basically factoring is the opposite of distribution. So we're going to take this and then work our way backwards. So we're going to break it apart and then take out the common thing and then bring it back up to there. Okay. So one of the ways to do this is to first off just kind of think of these as monomials. So just cover up one of them and then break that thing apart. Now, like I was mentioning before, the 6 can be broken into a 3 times a 2. X squared is 2x's, like that. I'm going to go ahead and draw a line right here just so that we can kind of separate those two, and I'll do this one in red as well. So 15 is a 5 times a 3, and then you got your x right there. Okay. Now, again, you cannot take anything out, because what we're basically going to try to do is take back whatever was given. So like right here, we gave a 3x, and then we're basically going to figure out, okay, what do they have in common that I can take back out? So when I look at these, I can see that both of these have a 3. So there's a 3 here and a 3 here. And they have to, it can't be in the same group. Like if I saw a 3 and another 3 here, say this was a 9. If I have a 3 and a 3, it doesn't count if it's all part of the same term. It has to be across the terms, because when you distributed to 2 different terms. So the 3's have to be the same in both of the groups, okay? This first terms group and this second terms group. So I got a 3 here and a 3 here. So I'm going to take a 3 out, cross them off. All right. And then I don't have any other numbers. So now I'm going to look at the letters. I got an X here and an X here. So I'm going to take an X out, cross them off, and that's about it. So now everything else is going to go back inside of parentheses. So I got a 2 and an X, and then I'll just bring down my plus sign, and then all that's left here is a 5. So that's it. And then make sure it's cleaned up. 3x is just a 3x, 2x is just a 2x, and a plus 5. So that's it. Okay. Now if you take a look at it, this is the exact same thing of what you started over here. That's why I said that it's kind of working reverse there. All right. So if you want to follow a type of algorithm here, finding the greatest common factor, here's some steps that you can do. The first thing is you're going to factor. Okay. Factor each of the terms. So that's basically just means break them apart. Okay. Find all common factors that are between all the terms. And then bring the common factors outside of the parentheses. Okay. So you're going to bring the common factors outside of the parentheses when you're done, and then put the rest of the factors back in. All right. So again, anytime I see a plus or a minus, I'm going to break these terms up. I got 2 terms going on here. I'm just going to draw this line. You don't have to draw this line, but just to kind of separate the 2 factorings that's going on. So I just cover up this 14x, go ahead and break up that 4x to the third. 4 is just a 2 times a 2, x, x, x. 14x is a 7 times a 2. Then an x. I can't break those up anymore. Those are prime, so that's it. All right, and then now I just find out what they have in common. Looks like I'll start with the numbers. They both have 2's. So I'm going to bring a 2 out, cross off the 2's so since I knew that I took them out. I don't have any other numbers. Now I'm looking at the letters. So I got an X here and I got an X here. So I'm going to bring the X out. Okay, cross them off so you don't confuse them again. And again, you cannot bring another X out just because you have 2 here. It has to be the same across these 2 terms. Okay, and then everything else goes back inside of parentheses. So on this side I have a 2xx. I'm going to bring right down this plus sign, and then I got a 7 here. And then clean this up a little bit. Just a little heads up, if all of your numbers end up coming out, like say there was another 7 over here, and you brought out a 7, and you had nothing left here, you need to make sure to put a 1. Okay, there's always going to be a 1 there because technically there's a 7 times a 1. So you can always just put a placeholder with a 1 if there's nothing left here. All right, and let's go ahead and multiply this out though. Just clean up this 2xx. So 2x, and then this is going to be 2x squared plus a 7, and then you stop there. All right. Common mistake I see a lot of people make, they get to here, and then they multiply again, they distribute back again, and they get this new answer that ends up being just the original problem. Please don't do that. This is factoring, not multiplying. Factoring means break it back apart. You broke it back apart again to a monomial times a binomial. You stop there. Okay, don't multiply it back together just to get back to your original problem. All right. All right, so again, I'll do these two, and then I think I'm going to just leave the back page to all of you, because after these I do's, if you need to kind of rewatch them, feel free to. All right, so first off, I see 3 terms. I'm going to go ahead and just, like I said, draw my lines. That way I can kind of separate them. Okay, I got a 20 n squared, so 20 can break into a 2 and a 10, and then a 10 is a 2 and a 5. And then I got 2 n's. Okay, so that's my first group. I got a 2, a 5, and then 2 n's. Okay, 20 again. I already broke apart a 20, so that's a 2, and a 5, and an n. So no need to do a factor tree when you just did one. And then 12 breaks into a 4 and a 3. 4 is a 2 and a 2. Okay, so I can underline these just so that they're a little bit more clear. Let me zoom in some. All right, so I got 3 groups. Got this first group, I got this middle group, and this last group. Now I can see right away that I have a 2, a 2, and a 2. So I'm going to bring out a 2, and it has to be in all 3 groups since it was a trinomial. I get another 2, 2, and 2. So another 2 comes out. And I got a 5, 5. There is no 5 here, so I can't bring a 5 out. I got some n's here. I got an n here. I do not have an n here. So looks like that's all I can really take out. All right, so put your parentheses back on. Okay, this first group is a 5, an n, and an n. I'm going to bring down this plus sign. I got another 5n. Bring down this minus sign, because it was right there, and then it's just that 3. Okay, and you took out the GCF. Looks like the GCF here was a 4, because 2 times 2 is 4. That's the greatest common factor. That's what they all had in common, was 2 2's, which was a 4. Now I just got to rewrite this as 5n squared plus 5n minus 3, and then you stop right there. That's taking out a GCF. All right, and let's do one more. Okay, and then just remember, feels like this is going fast. This is a video. You can always stop and rewind. All right, same thing here. We're just going to break these apart. I'm going to kind of space my groups out a little bit more just because I know that there's a little bit more numbers going on here. So 24 can be 6 and 4. 6 is a 3 and a 2. 4 is a 2 and a 2. And I got 3 x's and 2 y's. Okay. Now, as far as the x's and y's goes, if you can already kind of see that you have at least one x here, there's some shortcuts that you can take here if you can kind of see the variables. So feel free to do that if you want to. I don't mind. All right, 28. 28 is a 2 times a 14. Okay, that 2 is prime. 14 is a 7 times a 2. 7 is prime, 2 is prime. And then I have an x and then 3 y's. And let's go ahead and do the 12xy squared. 12 breaks into 4 and 3. 3 is prime. 4 is 2 times 2. Those are prime. I have an x and then 2 y's. All right. Now, if you, well, actually, let me finish this off before I start showing you some shortcuts. All right, so let's take a look at this. Looks like I have two twos. Well, I'll go one at a time. So 2, 2, 2. So a 2 comes out because it's in all three. I got another 2, another 2, and another 2. So another 2 comes out. All right, that's all the 2s I can really see here. So maybe let's look for a 3 because this one has a 3. That one has a 3. This one doesn't have a 3. So I think that's it for the numbers. Now let's go ahead and, oops, let's go ahead. Oh, I don't know if that cut out there. Hopefully it didn't. Okay, so let's go ahead and take a look at, all right, so took another 2 out. Nothing else. Let's go and take a look at the x's. So I got an x, and another x. So an x can come out, cross them off. And that's it for the x's. And then the y's, I'm going to go and take both of these out at the same time because I can kind of see them already. 2 y's, 2 y's, 2 y's. So 2 y's come out. And that looks like is it. Everything else goes back in parentheses. Now this gets a little messy, so hopefully you write this kind of clear. So I got a 3, a 2, and 2 x's. So 3 times 2 and then 2 x's minus, because there's a minus sign right there for this group, 7 and a y. Okay, and then plus, because there was a plus right there, that just comes down. And then all I got left is that 3 right there. Okay, and you can always double check right here and see, is there anything else that they all three have in common? Doesn't really look like it, so that's it. Just clean this up some. 2 times 2 is a 4x, y to the second power. 3 times 2 is 6, x squared minus 7y plus 3. All right. Okay, so I'll go ahead and stop there. Those are the I do's. That's basically how you break them apart. Again, if everything comes out, like if that 3 had another 3 over here and they were all gone, you would just write a 1 there, just as a little heads up. All right, and again, if you have any questions or anything like that, you can feel free to ask me. We'll probably cover this again on Monday just in case, but yep, hopefully it makes sense. All right, bye-bye.